Well, hi everybody, and welcome again to my shop. And here's our next project. This box. So let's look inside. Surprise! It's a record player. So our challenge isn't the mechanical side of this. This guy apparently hums and buzzes. Too many hums, too many buzzes. And where's he humming and buzzing from? Just pop that latch there, swing open this door, and voila. Take these apart here. There we go. So the speakers can be separated. Very cool. There we go. So, this is the Teletone High Fidelity Custom Automatic, made by Teletone Canada in, guess where? Montreal. Must have been like 100 million of these made in Montreal. So the amp will be in behind there. No doubt we'll have to take it out. But let's first listen to this guy at two separate volumes. So it's essentially two amplifiers, a left and a right. Okay. Doesn't look so good. It's on 33. Let's give it a little more. There's a little more to this than just a hum. I don't think that's 78. Not much traction on that. How about the hum? That's full volume there. How about in this one? Well, the first hint here is that they sound identical. In terms of the buzzier stuff, yeah, and it's still running really slow. Now, we'll have to track down what's going on with the speed. Not at all the issue I thought I was going to be looking into. Didn't stop. Did it? Well, the bearing on this is really nice. Look at that. That's quite nice. This is actually another BSR turntable. Whoa, made in England. Whoa, boy, that almost got away from you there. little tricky here. There we go. Motor feels fine. That may have been the problem. I had it on the power restriction. That may have been the whole problem. This feels pretty good. All feels pretty good. Yeah, I'm willing to bet that's all it was. Once again, I am the problem. That looks more like 33. Sure, that's all it was. Now, let's hear this up. It's much more distinct now. It would sound like a power supply hum. And you're raising the volume. Yeah, lots of sources of noise right here in my shop, so good place for testing this kind of thing out. Okay, so once again, back to what I originally thought. No need to deal with the mechanism. Question of fiddling around with the amplifier and seeing what we can do with it. So let's take that out. Two screws on the back. Green Roberts or Robertson? Somehow I can never seem to get that straight. The whole record player has to come up for us to get that amplifier out of there. Okay, there it is, the sheet of asbestos. The asbestos extends up behind the vacuum tubes. It's acting as a heat block, if you like. And I'm pretty sure it has a fairly good insulating factor. So you know, the backside of it is not going to get as hot as the wood would if the wood were just there alone. Two screws and out it comes. So I'm just going to leave that asbestos as it is right now. Now, I just want to lift this off of here as gently as possible, and hopefully there's no adherence to the asbestos. Okay, guess what? These knobs are going to be a little more of a problem. What happened? In many cases, let's pop them off. Oops, pop them is right. There we go. Take off those. Okay, gotta get out of here. Go through my pick the right size out of here. Okay, so I think I see it. I think this is it. No, it's a little too small. It's close. I think this is too big. Too big for sure. What if I don't have one? There we go. So these screws are actually part of what's holding the amplifier in place. These nuts. There's one. Okay. Now it should be a fairly easy thing to lift out that amplifier. Good show. There we go. And right away you can see it. 2 tubes, 2 output transformers, 2 volume controls. It's probably electrically 2 quite separate amplifiers in there. Okay. Try not to disturb the asbestos. Okay, and I see a couple of capacitors have been installed. See the old capacitors cut away. There in the back there, at the bottom. Yeah, right there. See, it's cut away. New ones are in place. See, it has a silicon diode. I noticed both channels were acting exactly the same. So I think we need to do a test here where we operate it and then short the inputs. Okay, so let's look a little further into this hum problem. And we'll need to have this running for us to do that. So for safety, we'll just put on the power restriction again. You can see the tubes here in the dark. You can see the tubes that lit up. Not that we need to see it, because we're going to hear it too. So. Okay. And there's the buzz, quite distinct. There's a little bit of hum there, but not much at all. So let's take a look at the voltage of the hum that we're hearing. The power I'm hearing. I'm pretty sure you can't hear this. There we go, that's a good spot for it. Okay. First we'll check the B+ level, just to see what we've got. $115 there. Oops. 115 and 92. Switch my meter to AC. Let's see if I can measure the hum level. .3. 5.2. Those are pretty suspicious. Well, a lot of meters you cannot do that. You cannot read the AC voltage with DC present. And I think this one's not capable. So, are we hearing hum from the power supply? Let's see. It's the same in both sides. It's identical on both sides, so I think it is coming from the power supply. 247 microfarad, and what's in there? 50 and a 30. So those two capacitors should be doing the trick. So I think it's the other noise that's bothering the owner. So let's examine that one. I'm pretty sure you can hear that. First thing I want to do is put a short on the input. So I'm just going to do one channel here. We'll do that channel. And what we're going to do, we're just going to short it. Okay, well, see, there's a fair bit of noise left. So, let's try shorting somewhere else. It's the other end of the same cable. Hey, you know what? If you're around my age, you probably watched Mission Impossible. And one of the characters on Mission Impossible was always pulling out clip leads and clipping stuff in panels and that. I was so impressed with that guy. Hey, look what I'm doing. Okay, so that took a little bit of the noise out, but certainly not enough to say that's it. Now, that's quite interesting. So where would that noise come from? Well, it's affected by the volume control, so we know it's ahead of the volume control. Boy, you know, it could be the tubes, but it would have to be each, you know, both tubes identically. That's a little hard to believe. Could one of them introduce a hum into both? Not sure. Like if one of them had an internal short, could it? It wouldn't. I just wouldn't imagine it would be the same in both channels. It would be clearly distinct in one. Really, the only thing they share is the power supply. So the components of the power supply need to be considered. Now, maybe that silicone diode is, I don't see how. Well, Let's try grounding the grids right on the tubes. So I think that's a 50 EH5. Oh, it's not in here. 50. Ah, I like that. Too new of a bulb to be in my older tube book. 50 EH5. Well, I noticed something interesting. When I touch what I suspect is the grid over here, you get more of that buzz. It's a little clearer. There's not much left here to introduce a buzz like that. Just seems to be right in the grid circuit, right from the volume control. I mean, it's real simple in here. It's just a volume control resistor to the grid. Here's the grid. Well, okay, so I think I got the situation diagnosed here. There's some kind of hum being introduced right between, or right in the very simple circuit that feeds the grid of the tube. How can this possibly be? There's really nothing there. So let me try and I'm going to ground out the signal again. So what I've done here is I've just put this clip lead that quiets it out. Hard to believe. This piece of red wire here. It's just comes. Whoops! It comes to here. Made myself jump there. That piece of wire appears to be the cause of the hum. That one on this side, and on the other side it's this one. Now let's see, these resistors, orange, mauve, yellow, they're pretty large. It'll go the other way, doesn't it? 47K. 47K resistors. So it's a fairly high impedance, but it kind of needs to be. Put a little piece of shielded wire through there.